Okay, so hello everyone. Am I audible?
Yes, sir.
Good. Yeah, it has been a long time since we met. Uh, okay, so the topic that we are going to discuss today is IT security. But before I delve deeper into the topic, I just wanted to get some feedback because we are already halfway through the course. So anyway, you are going to give the feedback as part of the mid-semester feedback. But I just wanted to get some verbal direct feedback from you. Okay, so I guess um, some of the things that you could tell me would be what you liked, what you disliked, what is it that you want changed to something else, or in terms of the assignments, or in terms of the exam questions, or the assignments. Uh, uh, I mean, assignments all are done. Project. So yeah, I think these are the different components. So if yeah, so in all these different components, what you liked, what you disliked, and what is it that you would like to see in a slightly different way, or what is it that you want to be done in a slightly different way. So yeah, please go ahead and tell me. I guess you can first raise your hand and then I could call out your name. I would definitely like to hear at least few of you. Okay, Ramita, please go ahead.
Sir, I found the assignments were quite interesting to do.
Okay, good.
And sir, the one part like email security chapter, in that more practical implementation of email hacking and all could have been like could give us insight into actual security threats in email. That's what I felt.
So more practical. Okay, so the assignments were good, but you need more practical um, examples or practical type assignments where you are actually hacking something, or you are, I mean, looking into something in that direction. Is it what you meant?
Uh, Sir, yeah, maybe like understanding how the email hacking happens, because theoretically we understand that this is how email sending works, but then practically how it happens.
Okay, okay, that sounds good. Yeah, so we are still designing assignment 3. We can design it based on your feedback.
Sir, it
Yeah,
should
thank
not
you.
be assignment, sir. It should be demo one.
No, that is something I guess you will learn only if you do it as part of assignment. By demo, you won't learn anything. You will hear it today, you will forget about it tomorrow. But if you do the assignment, you will at least learn, remember it for a semester, at least, even if you are not doing any research in cyber security.
Sir, one more thing, I
Yes.
really liked the fact that it was auto graded, because it saved us a lot of time, because usually by the time demo appears we forget things, and then we have to revise, and like it takes a lot of time for demo.
Okay.
Yeah,
So
that
auto grading helped.
helps. Yeah.
Hmm. Yeah, that is, in fact, yeah, so we put a lot of effort in uh, keep making this auto grading happen for the first two assignments. For the first, it was very difficult. For the second, it was relatively easier. Yeah, so we will see how we could continue to do that. Okay, good. Few more comments.
Hello, sir.
Yes.
So this auto graded thing also, like, I mean, for the fast assignment, it was confusing because like we saw the output in the auto grader, like it was visible to everyone, to us and the the TS. But like, I mean, we got confused that like whether should we like, I mean, put the results that we are getting in the auto in the report or not. So it was just a copy pasting thing. So I mean, we got confused and was like personally my mark also got reduced because like I didn't copy paste the output to the report. So I mean that was not specifically mentioned, like, and the autograded thing came after that.
No,
So
see,
there might
not
be.
everything can be thought out and written as part of the instructions. So what I will suggest when doing anything, whether doing the assignment or whether writing your exam, so try to do as much as you could within the limited time that you have. So if it is at the cost, even if it is at the cost of repetition, it is all right. So if you read papers, you read anything, you will see that the major idea or whatever you want to highlight is repeated multiple times. And yeah, so I would say that do not just try to do what is given in the instructions. Try to go beyond it and then try to put your own thoughts into what should be part of the solution and then put it there. So yes, so see, the assignment is being created by two of us. So one is the teaching assistant and the second is me. But then it is going to all of you, so around 85 students. And then all of you will think differently and then write the answers differently. At least that is what we expect. And therefore, if you think that you should be writing this solution in a different way, I mean, at least going beyond whatever is instructed. If you do not do at least what is instructed, then yeah, you will not be given full marks. But yeah, getting confused is something I don't know how to handle. But hopefully, if you try to go beyond what is being asked, then hopefully you will be on the right side of that confusion, not on the wrong side of the confusion. Okay. So what happens is that when I'm writing things in the assignment instructions, sometimes I start to feel that I'm getting very verbose. So I'm also, so the assignment is already 2 page, 3 page long. So that also prevents me in giving out more instructions. And probably it is also not good to write all instructions there because then it will restrict the choices that you will make as a student and it will restrict your innovativeness. Okay. Okay, so a few more comments. So let's just end it in next 2-3 minutes. But yeah, so probably you might like to give anonymous feedback, so that is fine. But at least some non-anonymous feedback is also good. No one? You like everything about the course? Okay, how was the minor exam for everyone? So let me take a quick survey. So we have around 28, 29 students here. So let me put a quick bracket. So not, so let me just put it this. So how many of you are going to score above 90 and how many of you are going to score below 90? So Can those who are going to score above 90 raise your hand? You are expecting to get above 90. Can you raise your hand, please? So all of you could raise your hand. So I could just see the number of raised hands and figure out. None of you are expecting to get above 90? Okay. And then let me just ask, how many of you are expecting to get less than 90? Okay, so some raised hands. Good. Okay, so it seems all of you are listening to me. That's good. Okay, it's fine. Okay, yeah, thank you. Now you could yeah, put down your hand. Okay, so let's wait for probably your midterm feedback. You might be more comfortable giving that feedback in the anonymous mode.
Sir,
Okay, yes,
may I share something about minor exam?
yes,
So I felt that time was less because like when they declared that it's 30 minutes left, I was still doing the second question. So
yes,
I didn't get enough time to answer third and fourth question because there were too many things in my mind, but then I could not write them. So
yeah.
maybe
So
my fault, I don't know.
So that is what is expected. In fact, that is very deliberate to give you less time than what it would have been needed by you to write the whole exam completely. So that is deliberately done. Um, yes, as an instructor, we have to do few things, and I would say that that is very deliberate to give you less time than what is required to write the whole exam. Okay. So see, yeah, so I would expect that we have a project which is, I mean, going to happen for 2-3 months. Then we have assignments which takes 1 week, and then you have these exams which are only 1.5 or 2 hours. So we are trying to test you on different skills, and altogether you will be graded um, at the end. So yeah, it is all right if you did not do well in this limited version exam, but try to do well in the other versions like assignments and project. So it is all right. Okay. Yes, Saurav.
Sir, I felt that the exam was bit too open-ended. Like every question required searching the internet rather than like applying the knowledge which we got from the lecture slides.
Yes, so no, no, no. So okay, so goal was not to uh, search on the internet. So as a so it was not my intention to tell you to go and search on internet. So if this was a closed book exam, what I would have done is I would have kept the similar questions, which were anyway going to be open-ended, but keep the number of questions smaller so that you would put your head and try to write that exam. But in this online mode, it is never possible to prevent students from accessing online resources. So it does not make any sense to not give any access to the internet. So you might have just another device sitting there. Even if we are recording, you can have another device to access the internet. So this does not make any sense. And therefore, I know that you will access internet. Now, if I know that you are going to access internet, then what I have to do is I have to give you problems so that if you start accessing internet, then you will not be able to solve the whole problem. But if you are doing if you are following the lectures and you just put your head and start writing on your own, there is higher probability that you will write more answers than someone who is searching on internet and then trying to figure out. So that was the thinking behind setting up this type of exam. But yeah, I guess I would happily hear your thoughts about how to balance all these things out and give you an exam which tests your knowledge, but also make sure that the students who want to cheat, they are discouraged from cheating. So yes, so the questions were open-ended, but it's not that they had multiple answers. So if you really think about them, you would always have only probably two options or so, and you have to decide what option I should choose and how to explain that option. So a real open-ended question means that there are no correct answers. Whatever you write would be like a social science answer that or psychology answer that whatever you write is going to be correct. So it is not like that. So there would always be, probably that is what I was thinking when putting down these questions, that okay, there would be probably only two options, two right options probably. Yeah, let me just say that. Of course, the wrong answers could be infinite, but there could be only two right answers, and let's see if the students write any of those two answers or not. Okay, so that was my goal. So sort of, so what question did you feel that it had many answers? Did you feel that there was a question which had many answers?
So like in
More than two?
second
Yeah.
and third question, I couldn't figure out like what exactly we could do in them.
Okay, let me just see.
So would you share the solutions?
No, I will. I do not plan to share the solutions, but I plan to discuss the solutions. Let me just quickly see. Yes. So second question, email security. Okay, good. So yeah, thanks for bringing this out, Saurav. So see, this was just testing your understanding. There was nothing unique about a blind receiver. So let me just clarify that part. Probably you were searching on internet and trying to figure out what is something unique about the blind receiver. So there was nothing unique about blind receiver. This was just testing your knowledge, whether you understand the email discussion about sender and receiver correctly or not. So if Saurabh, if you were thinking that you should do something interesting for this blind receiver, probably you were going in the wrong direction and searching the internet for the
Sir, I
wrong
thought
answer.
that we are required. So I didn't know that how the identity of receiver was sent. So I was searching like in SMTP where the identity of server is put, so I could change
I
that part.
see.
So
Hmm.
my most of the time was wasted in searching this, that where the identity of server was kept in the that protocol.
Oh, I
So
see. I see. Okay. Hmm. Yeah, I could have made things more clear probably. So let me just quickly discuss one potential answer for this email security. Okay, so let me see if I could, yeah. So what the expected answer that I was looking for was that you would have a sender, okay, and then you will have three receivers: primary receiver, secondary receiver, and blind receiver. Okay, and then what you will tell me is that I have a message, then I utilize a digital signature. So message M, I utilize a digital signature of the sender, and then I have a secret key which I will utilize to encrypt the message. Um, and so this is now the encrypted version, and now this key, this will be first encrypted using the public key of the primary receiver. Then another thing will be, so it will again be encrypted using the public key of the secondary receiver, and then it will again be encrypted using the public key of the blind receiver. So you will have all these things together, and then the encrypted content here, and then this will be transmitted, and then the primary receiver will receive that message. It will take out the one of the parts and then decrypt it, and then so basically what I was expecting is for you to write what was taught in the class. So definitely I did not go into the details of how emails work. So what is the structure of a real email message? So I did not discuss all of that. So of course I was not going to ask you as part of this limited time exam. So 1.5 hours is a very limited time. So I was not going to ask you to write something which I had not taught in the class. So hopefully now you see what answer I was looking for. Is this clear, Saurav, what answer I was looking for?
Yes, sir. Yes.
Yeah. So I was not looking for an answer that there is some structure of the email message that the sender is following, and then you have to somehow encrypt some identity somewhere. So I was not expecting that you will do that. So I was just expecting the same sender figure and then the 3 different receiver figures, which will almost look very similar. Okay, so there was nothing very I guess it was a little confusing, and I deliberately put this blind receiver there. That was also deliberate to see if you understood how. So the reason is that in any case, when you reveal the when is it that you need to reveal the identity of the receiver? So or let's say the sender. Okay, so when the sender utilizes its public key, sorry, the sender utilizes its private key to sign something, then, and if you need the public key of the sender to verify the signature, it means that the sender's identity has to be there. So public key has to be related to the sender's identity, and that is where you reveal the identity of the sender. But when we are thinking about the receiver, you could take anyone's public key and encrypt it. But other receivers, they don't care much about who the blind receiver is, because they are not interested in decrypting that message in any case. They cannot decrypt it because they don't have the private key. So they are anyway not interested in it, and they will not figure out who would be that receiver. And therefore, yeah, this identity stuff that I wanted to highlight was related to the usage of public and private key. So that is where I wanted you to think in that direction, but probably, yeah, I could have rephrased the answer to make it less confusing. It was very open-ended. Yes, that is true. But so, okay, so I would say that in the major exam, try to follow whatever I have taught in the class and try to think only in that direction. So whatever I have not taught in the class, I do not expect you to write in the exam. Okay, so we have 2 raised answers. Ramita, please go ahead.
Sir, in the book I had read somewhere that if there are multiple receivers, there needs to be a common encryption algorithm which all of them support. So, like suppose if they do not support, then 3 messages will be sent. So that part I mentioned in my answer.
Yeah, that's right. So I said that this is just one answer. If you have went beyond this answer and did something more interesting, I would be happy to read. So this is just something that I also want to see, is that different students have written different answers, and some of you may be innovative enough to write a very, very unique answer. And yeah, I would definitely like to read such answers. Yes, Subrat, please go ahead.
So I have a question actually. So,
Yes.
so when IIT Delhi is sending like mail to every student, so is he appending all key, or like it is a kind of a broadcasting?
To all students.
I mean,
No, so yes, so
I mean
all
there are,
students.
yeah. thousands
that
of
is,
receiver.
yes,
When the receiver are like very large.
yes. So you would also have seen one message, or you would think that so when you have, so when you send to all these messages, then as the number of receivers increase, then the time to actually send the message also increases. Okay, so the computational time also increases. So any message that is sent to this all the students, so all the students is not an email address, so it is a group address. And if you see what are the email addresses in that all student at whatever iitd.edu, you will see that there are so many um, receivers there. So then all those messages go to all those receivers, and then that message has to be stored and retrieved by each receiver. So it is not that there is one common location where they are retrieving that message from. So it is not like that. Every receiver has to access its own mailbox and then retrieve the message in its own mailbox. And therefore, for each receiver, you will see, so not different encrypted content, but different in differently encrypted key. So that secret key that we have here, you will see that for each of the receiver, the key has been encrypted again, and that is the reason why you may see that if there are large number of receivers that need to receive that message, then the time to actually send that message is significantly large. Any other question? Just let me also
Sir,
quickly see. Yes.
sir, in your expected answer for this question, so why you are expecting that the sender will also encrypt the one-time secret key using this public key of blind receiver?
Why was I expecting that? So you
Yes,
think that so
because
without
blind receiver,
go ahead.
yes, sir, because blind receiver should not be able to read the message, so he should not be first
No.
decrypt that. Yes.
No. So think about this, that your primary receivers are people who you send by putting their email address in that two block of the email, and then this you could think of the CC ones, and this you could think of BCC ones. And even the BCC ones, okay, so the sender does not want to reveal so sender does not want to reveal its email address. So the receiver's email address should not be revealed to the original and secondary receiver. So this is only about email address. It is not about the content. So if you are sending some content to the blind receiver, of course it wants to read that content. Did you get confused about this, that the blind receiver does not
Yes, sir.
need to read the content?
Yes, sir. Yes, sir.
I
I got confused like this. So
I see. No, the blind receiver also needs to read the content. So probably.
okay,
Yeah.
means the privacy should not get revealed to the blind receiver only. The content.
Okay. Yeah, I think I should be more explicit in my requirements when I create these questions. I will keep that in mind next time, but yeah, this time I guess okay. I cannot probably help at this time. Okay. Any quick question? Okay. So yeah, so about this question 3, Now that I have told you what I expected in problem 2, can somebody quickly tell me what I had expected in problem 3? What you could have written in problem 3?
You explain level of security. So second level, third level already you
Yes.
explained. So second
Yeah.
level of security it was needed. And solution pin already you told some video pin authentication.
Yes. Yeah. So what was the solution?
Pin
Can you-
you told na pin should be generated some
In
OTP.
yeah, that is definitely possible. One pin-based solution is also possible. Okay, and then hopefully you wrote something about it. So yeah, so I was not expecting you again to go online and search for the answers. I was just expecting that you will think about, okay, let's do level 2, probably level 3, and then if we want to have a security pin, what can we do? And then just make your argument. What are the issues in the defense that you are proposing? There could be some. So you are definitely proposing a solution, but there could be. So the good part is that now your headphone will be more secure. But what is the bad part about your solution? So that is what the third part was asking for. Okay. Okay. So hopefully in the major exam, you will not go directly to look for answers on the internet. Try to think on your own and then write answers. Okay. Okay. Any last questions before we move to our next topic? Any quick question about the minor exam? Something that also got you confused. So I already talked a little bit about 2 and 3. Any other thing that you got that got you confused? Okay, so you will get hopefully some comments as part of that grading rubric as well. So we will see. Okay. 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 So now let's move to our next topic. So we have talked about some application layer or applications. So for instance, accessing a web server or this email handling system, or we also talked about SSH and how to do transport layer security. So the transport layer security, TLS and SSH, you could think of in the same line. So we have already talked about these things. Okay. So now, so here, so in this figure, first of all, for those who do not have much networking background, I hope that you have, but if you do not have, so what we are showing you here is a protocol stack, which you can think of starting from the application layer. Okay, so different applications that might be running on your platform, and then you have this. These applications could be anything. So it could be email, it could be just accessing a website. So all of that is considered an application. And then how do you stream your data? So typically there are two ways, either UDP based or TCP based. Okay. And then this layer, network layer, this is the one layer which actually determines where is the destination of that packet. So your once you have segmented the application data, you have added some sequence numbers, and now you want to send that data over to the receiver. So what you need to do, you need to add an IP address to your packet so that it could be read by the switches, routers, and then it could be directed to its destination. And that is the goal of this network layer. And then the link layer is something which actually allows this communication between different entities. So if you are connected to Wi-Fi, you are actually using different link layer protocol. If you are using Ethernet, it is different. If you are using a mobile phone and using cellular network, it is different. So that is where link layer works. And then at the physical layer, things could be, again, there could be many different things to do at the physical layer. But basically, you could think of a wired connection or a wireless connection. And so you might be thinking about communicating it as by changing the amplitude of the signals at the physical layer, or changing the frequency, or changing some physical layer parameter to communicate the bits ones and zeros. Okay, so this is the protocol stack. And then this, what I want to highlight here is that this IP sits right in between. And it is one layer which you could think in the form that it makes sure that whatever application you use, it is at this network layer, the packet will be processed in similar ways. So this packet will not differentiate. If you have created such a policy about the packet, it will not differentiate whether the packet is containing the data corresponding to an image, whether it is containing data corresponding to a video, or it is something just corresponding to an email content. So this layer won't worry about those things. So here, the goal of this network layer or IP Internet Protocol processing is to just make sure that the packet could be delivered to a particular destination, which means that you are going to add an IP address in a certain way. Okay, so we will be talking about this layer of the protocol stack in this lecture, and probably, because we don't have much time, in the next lecture as well. Okay, so again, at the IP layer, so what we are going to do is to add an IP header. So Internet Protocol header, which means it will contain it may contain what is the source IP address, what is the destination IP address, based on the protocol that we select. But at a high level, you could think that there will be a header, an IP header, which will be concatenated with the packet. Okay, so and this will be the header. And we are thinking about how to make sure that we provide these different security properties. So we have been talking about encryption and authentication, and you have seen how it is provided in TLS, you have seen how it is provided in SSH, how it is provided in webmail. So all of them are being provided at different layers. And now what we want to do is to provide very similar things at network layer. Okay, and okay, so before I talk about it, so can someone tell me why is it that we have to provide the same security properties at different layers? Can't we just have this security at one layer and it will work? Why do we need to provide these security properties at different layers of the protocol stack? So let me go to the previous slide. So why do you think we need to have security at link layer, security at network layer, security at application layer? Why is it that we need security at all these different layers?
Sir, different devices work at different layers, so we need to provide different layer security.
Different devices.
Like router works at network layer, link switches work at that link layer.
That is one good motivation. Good. So as Ritik is mentioning, that there would be some devices, mostly in the to provide this network infrastructure. They will not like to go down until or go up in this figure, go up until application layer to decode or authenticate the data and then decide whether to process that packet or not process that packet. And therefore, you may want to make sure that that decision is taken at a much lower level. So that is one motivation. Good. Any other motivation?
End-to-end security.
End-to-end security. Okay, so that is a good name. So very summarized name. So typically, what is the meaning
Also,
of
sir,
that end-to-end security? Yeah, that is what I would like to hear.
Sir, data which has been generated by an application, it can only be decrypted by another application for which it was intended.
Okay.
So it should not be happening that the devices which are handling the data between the application layer and the physical layer, they should be able to get something out of that data.
Okay, so then you could have just had encryption at the application layer, and you do not share keys at lower layers. So what is the problem in that case?
At every layer, we will add the header.
Yeah, each layer adds a header to the data payload. So we need to add security for each layer as well.
Okay, yeah, that is also fair to say that there is always some new content in terms of the header that is being added at different layers, and therefore it would be nice to authenticate, at least authenticate, or if you want confidentiality, encrypt those additional information or additional header information that you are adding at different layers. Okay, so that's very nice. Okay, good. So we already have some good answers.
Also, sir.
Yeah.
Also, sir, we have seen in the previous lectures, like in BLE stack, the loophole was there. So because of non re-authenticating the users. So by providing security at application layers, means at each layer we can also patch these holes.
Yes, yeah. Thank you for bringing that up, Suraj. So yes, so I would like to add to your answer that so the BLE example that I gave some time ago, remember I used a smart ring to demonstrate the attack. But what I did not tell you probably at that time, but I might have told you that we were not able to demonstrate the same attack on a smart watch. And the reason was that, yes, so in a smart watch also, we were able to show that this link layer security was broken. And in smart ring also, we were able to show that link layer security was broken. So in both the cases, we were able to show that the link layer protocol, security protocol was broken. But in a smart ring, there was no application layer security. Okay, and therefore, once this link layer security was broken, we were able to demonstrate all these nice things in that attack video, that we were sending messages and the app was receiving messages and the app was also interpreting those messages. So we were able to show all that on a smart ring because there was no application layer security there. But in the case of smart watch, although we were able to break link layers security, we were not able to break the application layer security. So there, although we were able to send messages, we did not know. I mean, the first of all is that we were not able to do any reverse engineering to understand how these messages are being interpreted by the app when these messages are received from the smartwatch, or how the app is sending messages to the smartwatch. So we were not able to do any reverse engineering because of the encryption that was happening at the application layer in the smartwatch. So very nice. Thanks for bringing this up. So having security at different layers will have this advantage that even if the security is broken, somebody finds a security vulnerability at one layer, then even in that case, it is possible that they might not be able to do much harm to your application because you have security at other layers. Okay. 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 So now let me just highlight the fact that it is transparent to applications. So that is what is very important to notice, that no matter what kind of application you are using at the network layer, if you want to add IP security, you can define some policies, but it is basically transparent to applications. It is just looking at the packet coming from the transport layer, and it can process that packet. Okay, so when we think of adding IPsec, there are two methods of doing it. One is authentication header. So as some of you have already mentioned, that at each layer there is some header that is being added. And when initially people thought about IPsec, they thought about only authenticating the header information. And therefore, this is authentication header is one of the methods of IPsec, but it is already outdated. People typically do not use this method. And the second method is encapsulating security payload, so ESP method. So ESP method is something that is typically utilized these days. Okay, now one other thing that I want to highlight on this slide through this figure is that how your IPsec will actually, how you would visualize it in a real network. Okay, so you might have used VPN. If you are at home accessing IIT Delhi's server, you must be using VPN. So what the VPN provides or how this VPN functions is very directly dependent on the security that is provided by IPsec. Okay, so what your VPN does, it gives you a unique IP address which you could utilize to access IITD's servers, and that is how so the communication between your laptop after you run that VPN service on your laptop, and then IITD's firewall, let's say the firewall on so your whatever packet you send may be utilizing IPsec, and then it might be getting transmitted over the internet, and then our servers here at IIT Delhi or the firewall here at IIT Delhi might be receiving those IPsec secured packets, and then it will direct the packet to the destination which you want to access, whether it is HPC or whether it is mail or something else. Just e-admin portal, it is for faculty. There might be a student portal that you want to access. So different things. So if you are using VPN, you are probably using IPsec. Okay. Okay. So now what I am trying to highlight is that this authentication header method, which was developed first, and which is something outdated, as I already mentioned, it only takes care of authentication and integrity related issues. So it will take care of access control, connectionless integrity, data origin authentication, and the rejection of replayed packets. So we will talk about this issue later, but basically this is also related to authentication. So if you authenticate a packet and then you figure out whether its packet is repeated or not based on multiple criteria, and authentication is one of them. So this edge facilitates that. Okay, so then we have encapsulating security payload, so ESP method. Now that ESP method has two ways to do it. One is to do it without authentication, which means that it will provide only confidentiality and some sort of access control. So in this ESP mode, without authentication, that is an option, you are only doing encryption, and therefore you are providing confidentiality, you are providing limited traffic flow confidentiality, and the encryption will also help in rejection of replayed packets as well, and the access control is also possible. But the full-fledged ESP with authentication is another option with the ESP method, and there you provide all these different properties, so which are related to authentication, prevention of replayed attacks, and confidentiality. Okay, so I hope at least these two options are clear to you, because this is something that you will see in current systems. So ESP without authentication, ESP with authentication. Okay. Any question about the things that we have covered until now? Okay. So I want to skip this slide and then yeah, discuss this slide first. Okay. So the ESP method. Okay, so the ESP method, as I said, it can be done with authentication or without authentication. Okay, but then there are two other options as well. Okay, so without too much getting too much into these different options, but just giving you a very high level idea of these different options, because there are significant differences. Of course, if you read the book, you will see a lot of details about IPsec, but I will not go into that much detail, but some detail has to be given. So as I said, ESP had these two options: without authentication, with authentication. But then this ESP method could be implemented in two other modes as well. So both. So you had encryption and then encryption with authentication. So these are two options, and then you have these two options which are called transport mode and tunnel mode. So these are two different options. So now you have actually four options. So the combinations of these two will result into you having four options. So there is one something called transport mode, and then there is something called tunnel mode. Okay, so tunnel mode is something which is the most attractive use of IPsec. So as the name suggests, tunnel, it is something that will provide you complete, it will provide complete protection to the packets which are coming from the transport layer. So okay, let me first show you this diagram. So I have two diagrams here, one on the left and one on the right. Okay, so if you start from this left diagram, so we have this application layer, we have this TCP, we have this IP, and then this figure is showing where does this IPsec sits in the transport mode. Okay, so you see that at the application layer we have some data. Okay, and then at this transport layer you will add this TCP header, and so you will concatenate that TCP header. Okay. And then at the IP layer, you will add some IP header as well. Okay, so now you have IP header, original IP header, TCP header, and data at the IP layer. And then IPsec kicks in. Okay, and what it does is it yeah, I have not shown you. So what it does is it adds this is the ESP mode, so it adds some values here, and what could be those values? So you need to encrypt and authenticate the TCP header and the data. Okay, so in the transport mode, what you are trying to do is you are trying to only encrypt and authenticate the information that has come down from the transport layer, which means TCP header and data. So those are the only things that will be so those are the only things that you are worried about. So you are not worried about encrypting and authenticating this original IP header in the transport mode. Okay, so in the transport mode, you are only trying to encrypt and authenticate data that is coming from the transport layer. So you see this transport word terminology there. So you are only looking into this TCP header and data. Then you are adding some ESP header. This ESP header will have information about what option of ESP you are using. Is it with authentication or without authentication? And then you might need to do some padding and stuff. That is what this ESP trail means. And then, of course, when you're authenticating, you will generate an authentication tag. And that is what this ESP auth means. So a message authentication code based on ciphers or an HMAC. So that is what this ESP auth will mean. So here you see that the original, so that is what I want to highlight, that the original IP header is not encrypted or authenticated in the transport mode. Okay. Okay, so now let's look into the tunnel mode. So in the tunnel mode, you start with the application data. You see that at the transport layer, you have this TCP header. Then at this IP layer, you added an original IP header. But then something different happens with the IPsec. Okay, so what you did was you took the whole thing, the original IP header, the TCP header, and the data, and then you encrypt and authenticate all three of them. Okay, so all three of them are now encrypted, but because the IP header is now encrypted, you need to add some new IP header, isn't it? So if without an IP header, you cannot send the packet to any destination. But now you have encrypted it, so it is now just a random sequence of bits, and therefore you go back to the IP layer processing, and then you add a new IP header, and then send that data over the channel. So you see that in the tunnel mode, so tunnel means that, of course, your TCP header and data was encrypted, authenticated, but your original header is also encrypted. So no one over the internet would be able to even know where the packet is headed. So where actually the packet is headed, because the original IP header has been encrypted. So of course, this new IP header, it will give some indication of where it is headed. So for let me just give you a quick example. So as I said, there might be a firewall at IITD's end where the packets might be getting received. And then after the firewall, the packet will be sent to the original destination. Okay. So when processing the packet at this IP layer, your platform might add your the original IP header. So original destination of this packet. So probably let's say this destination D1. Okay, but at the second IP layer, so now that this is encrypted, authenticated, so now that you have to add this second new IP header, what you could do is you could just directly give the IP address of this firewall. Okay, so your packet will be delivered at this firewall, and then when this firewall will be able to decrypt this packet, it will figure out what is the original IP header, and then it will forward it to the original destination D1. But anyone looking at the packet over the internet, they will not know that this packet is destined for D1. They will only know that this packet is going to that firewall. Okay, so you see the reason why we have these two different modes, transport mode and tunnel mode, and why we have these two IP layer processing in the tunnel mode. Okay, so this was something that I wanted to discuss first. So I will also talk about encryption authentication later, but we will have to conclude our session today. Any question related to these two different modes, so transport mode and tunnel mode?
Sir, one question.
Yes.
Sir, like as you told in the destination part in the tunnel mode, we will use the firewall destination address.
Yes.
So what will be used in the source address? Like what will be the new source IP here?
So source IP could be, again, it is dependent. So let's say that your system, so let's say the sender S1 is also behind a firewall. Okay. And then you have the internet, and then you have this firewall at the receiver. So this is the firewall at the sender, and then you have the receiver. So if you think about it, if this firewall is actually doing this IPsec for you, then the source address could actually be of the firewall. It is also possible.
Got it.
Otherwise you could, if there is no such firewall or something, then the source address could always be the sender.
So it will be the private IP, like we get 10 dot something in the new IP header.
Yes, so the IP address is the same, the 10.20.1.4 or whatever you might be receiving as an IP address. That is the IP address that we are talking about. Okay, so we will again take some questions on this architecture, and I will also talk about these modes again in terms of processing of IPv4 packets and IPv6 packets. So hopefully this discussion will happen again. Okay, good. So let's meet again tomorrow. Yeah, bye bye.